Hello Matthews, Gatos here. In this video I'm going to show you that shortcut to doing a sine regression equation on your graphing calculator. So I'm going to take you back to the example that we did in section 5.4, the hours of daylight by day of the year. In this graph we had day number and hour number, and we went through that process of finding A, B, C, and D. We ended up getting this equation here, 3.1 sine pi over 183 x minus 80.5 plus 12.8. I just put the pi over 183 as a decimal because my calculators are going to use decimals, so I just want to be able to compare it. So this was the equation that we got. I'm just going to take you through the process of how to solve using a regression and see if we come up with the same equation. Then I'll do two more examples where I'm actually using my calculator so you can see all of these steps. Okay, so the first thing that we need to do is set up our points ready to put into the graphing calculator. Your graphing calculator has this spreadsheet kind of thing. It's kind of like a little Excel spreadsheet in your calculator. So the very first thing that we need to do is enter these points in the table of value into our calculator. I'm going to show you the steps in the next example. I'm just going to take you through slides of how to do it first. So to set it up, you're going to go into your stat, which is your spreadsheet. So we're going to go stat, edit, and then we're going to have this blank sheet ready to fill. In list one, I'm putting in the daylight hours. So I'm creating this table of value on my calculator. So this is the day number. I'm just putting it in my calculator under list one. Then I'm going to take list two, which is the hours. So this is my y coordinates, which are all of the values on my table right here. The y values are going into list 2. So in list 1 go my x values, in list 2 go my y values. So I just enter those one at a time, pressing enter to go from row to row to row. Once I've entered them in, I just want to make sure that my mode is in radians. So just like for any word problem I'm dealing with radians, same thing on your calculator. So you have to be in radian mode. Okay, so we've entered all our values into our calculator. Now what we're going to do is turn the plots on, which means I want to plot some points. So I don't know if you've ever noticed these, but in your y equals, there's these plots up here, and we always have them turned off. So what we're going to do is go up to the top of y1 and press enter to highlight plot 1. Then there's this really great window setting on your calculator called Zoom 9, and it's Zoom Stat. The reason it's called Stat is because over here, to get into here, we went into Stat. So basically the calculator is taking all of your points in list 1 and finding a good window setting for x. All of your points in list 2 and finding a good window setting for y, and it does it for you. Now because we turned our plots on, when we hit graph, we see all of these individual points. So I can see that should be like a little sine wave. Now the window is being fit, but I always want to make sure I can see the origin. So I know I can see the origin because I have a solid line here for x and y, but I always want to see the origin. So Zoom 9 is a good starting point, but make sure you can see the origin. Okay, so now that we've put all our values in, we can see the graph, we want to find the equation that goes through all of those points. So this is my next step. I'm going to go back into my stat, but I'm going to go over to calculate, and I want to calculate a sine regression. Now all regression means is it's an equation of best fit. So it's the equation that goes through as many points as possible. So we're going to go into sine regression. We're going to leave this at one iteration. My x values are in list 1, my y values are in list 2. Leave your period blank. And this is really important. We want to store the regression in y1. So this is kind of like on your on your computer, how you go Control C to copy it, and then you do Control V to paste it. This is like the copy paste. And so we want to tell where we want to copy this equation. We want it to go into y1. So if you have an 83, to get the y1, you do vars, yvars, enter, enter. If you have an 84 or newer, you just do alpha trace to get the y1. Okay, so when you do that and you press enter to calculate, this screen comes up and this is your sine equation. Now this equation looks a little bit different than how we're used to seeing it, because we're used to seeing it as a sine of b is factored out. B minus C all plus D. That's how we're used to seeing the equation. So all we have to do is factor the B out. So the tedious part is entering the points in and then factoring the B out, but it's way easier than doing it the other way. So I'm going to take this equation and set it up to look like this. So here's my equation, bx plus cd. So I plug in my a value, my b value, my c value, and my d value. Okay, just right that I've got here. And then all I do is I factor out my b. So I factor out as 0.016 from both terms to get my equation. So this is my equation on my calculator. Let's see how that compares to the answer that we got. We got, doing it the other way, this equation. So look, your a value is the same, your d value is close, and these ones here are close. So everything is really close. Now my question is, which one do you think is the more accurate equation? And the answer to that is the graphing calculator. This is the most accurate equation because it uses all of the points of the table. Our equation only used the max and the min on the table. So the calculator is a little bit more accurate than the way we did it before. But that being said, both methods are acceptable. So I just wanted to show you that with an equation that you already knew the answer for. So let's look at a question that you don't. Okay, before I mention that, here's that copy paste. So it has the equation into y1, and this is great because it doesn't round it. And then when I hit graph, there's my nice sine wave. Now, as soon as I do my graph, notice I don't have the little dots anymore. It's because I turn my plots off. I deselect them. So see how they're not highlighted anymore? And I do that because any calculation I do is much easier if my plots are off. Okay, now let's go to your homework questions and let's do one together from start to finish. So for this equation here, I'm going to go and set it up on my calculator and show you how I do all of the steps. Okay, so let's set my calculator up ready to go. I just want to be able to see my table of values though. Okay, so the very first thing I do is I just go into my y equals and I make sure everything is clear. Then I go up to my plot 1. So I just did up arrow. So see, I'm here. I just go up arrow to plot 1 and I press enter. And now it's highlighted. So I'm selecting plot 1. Okay, next thing I'm going to go out to my main screen. I'm going to make sure I'm in radian mode. So I am in radian mode. I'm good. And then the next thing I'm going to do is clear my lists, that spreadsheet function. I don't want anything in there. So it's almost like I'm clearing my calculator. I go second plus sign. And to clear your calculator, you would choose option 7, which is reset. I'm going to go to option 4, which is clear all lists. And I press enter. Okay, so that's done. So now I'm ready to take this table of values and put it into my calculator. And that's all done under the stat menu. So I'm going to hit stat, which is right here to the right of my variable key. I want to edit, and there's my little spreadsheet. So I'm going to go into list 1, and I'm going to enter in the month numbers. Now the month numbers are, I just want to double check here, from 1 to 12. So I'm going to enter 1, and then press enter to get down to the next row. And I'm just going to do that, and just take your time, because we want to make sure that we don't make any silly mistakes as we're entering these in. So just enter to go from line to line. And as I'm doing that, when I'm done, I go back up and I just do one more check just to make sure I'm counting it down in my head to make sure that I did that correctly. And it looks good. Okay. So now I go over to list 2 and I'm going to enter in my temperatures. Now, this is negative 19. Make sure you don't use your subtraction. That's an operation. Use your negative key. So negative 19, and then just press enter to get down to the next one. Negative 16, negative 8, And I really take my time with this because one little mistake and the whole question falls apart. So really take your time. This is the tedious part, but it's definitely worth taking your time. 18, 12, 6, -5, and what's my last value? It is -14. Okay, and then I'm just going to go back up and just double check one more time to make sure I haven't made any silly mistakes. When I do this in class, someone can yell at me and say, hey, you made a mistake, but here I'm on my own. Okay, so we're good on that, so I can make this bigger for you now. Okay, so we've entered in all the values for list 1 and list 2. So let's get out of here, second mode, and let's go into our set our windows. Remember that trick I showed you? Zoom, and then option number 9, zoom stat, takes all the windows in our stats in our spreadsheet and it sets it. Okay, I do zoom 9 and then it went right to my graph here. So here's my sine graph. I want to find the equation that goes through all of those points. So out to my main screen, and here's where I'm going to do my regression. So I go back into stat. I've already edited the points. I want to calculate a regression. So these are all the regressions that your calculator does. Let's just talk about a couple of the important ones as I go by. This is a linear regression for lines, quadratic regression if it's like a parabola, cubic. This is a log regression, exponential regression, and here's sine regression. So that's the one I want. So I press enter. Okay, so iterations just 1. X is in list 1, yep. Y is in list 2, yep. Ignore the period. And here's where I want to store the regression. I want to copy paste it into Y1. So I want to tell it I want it to go into Y1. So I'm going to go alpha trace, and then I want to copy it into Y1. And then I press calculate. Press enter. Now, here is my sine regression. This is my equation. I'm actually going to copy this over because I feel like we need that as part of the question. So I'm going to copy that. Let me just put it in my notes really quickly. There we are. Okay, now let's go back to the calculator and let's hit graph. And there we go. See, it's going through as many of the points as it possibly can. Okay. So as soon as I've done that, I just go in here and now I'm done with my plots. I can turn them off. I just want the equation. I don't want the points anymore. So I use the points to come up with the equation and the window setting, but now I don't need them. Okay, so let's go back to our notes and see what we need to do. Okay, so it says develop a sine equation that models the following data. Okay, so all we have to do is put it into this form here. Now remember that this form here is with the b unfactored. So I'm going to write 2 equations. So I'm going to have y equals a, we'll go 19.3, and then times sine of b, 0.5x plus c, well it's a minus 2.03, and then plus my d value of 1.4. Okay, so that's how the calculator does it. We like to have b factored. So I'm going to write it as y equals to 19.3 sine of, I'm going to take out b. So I'm going to factor 0.5. So 0.5x divided by 0.5 is just x, minus 2.03 divided by 0.5. When I divide by 0.5, it's kind of like doubling. So it's going to be 4.06, close my bracket, plus 1.4. So that would be my equation. So the time that you spend developing the equation is really putting it into the calculator. Once it's in the calculator, it's a simple matter of factoring b from your equation. So that's my equation. Now let's look at how we answer the question. There are 30 days in April. Use the model to predict the average temperature for April 15th. So this is month number. This is an example of x given, y needed. So x given, y needed. So whenever we have an x value that is given, we're going to use trace. Now, if there are 30 days in April, April 15th will be halfway through the month. And April, January, February, March, April is the fourth month. So this is like saying I have an X value of 4.5. What's the Y value that goes with it? So into my calculator, I can hit the trace button and go 4.5 and press enter. And that would be the Y value that goes with it, 5.97. So we'll call it 6. Okay, so then I can say that the temperature is going to be about 6. And it would be, temperature I believe is in degrees Celsius. Doesn't say, does it? Or no, it doesn't. But I'm going to assume it's Celsius, 6 degrees Celsius. And then we're done with the question. Okay, let's try one more. Practice number 9. So this table shows the average monthly temperature, there we go, degrees Celsius, for Winnipeg. Get it, Winnipeg? It's actually Winnipeg, but that's the nickname because it's always so cold there, with the exception of August. So August isn't given to us, so we're not even going to put that into the calculator. Determine the equation of the sine function, and then we're going to state the average temperature for August, talk about the parameter D and how it would change if that was temperatures for Veradero, Cuba. Oh, wouldn't that be nice to be there right now? Okay, so let's look at the steps again to set everything up. So I want to clear my y equals. I'll go into my y equals, clear it, go up to plot 1 and select it. Okay. Out to my main screen. Now I already know I'm in radians. I can see up here that I'm in radians, but I would always make sure that I check that. I'm going to clear my list. So second plus sign, like I'm going to be resetting my calculator, but I'm actually going to be clearing my lists. Okay, now I go Stat, Edit, and this is where I'm going to enter in the list information. So in L1 is going to go every temperature, every month except for August, which is the 8th month. So 1, 2, 3. Oops, I'm in the wrong one. Let's try that again. Let's go over here. That's where I'm supposed to be. 1, 2, 3, 4, 5, 6, 7. We're not doing 8, 9, 10, 11, and 12. Perfect. Okay, now we're going to go over to list 2 and we're going to enter in the temperatures. Okay, so the first temperature is minus 19, negative 19, and then negative 16, and negative 8. Now I've been to Winnipeg. These are definitely temperatures without the wind chill. 3, 11, 17, 20, and then I can't see the rest of my table. Okay, then we've got 12, 6, negative 5, and negative 14. Now, as I go back up the table, I always just like to check to see if I've done that correctly. And then negative 8, let's just see, negative 8, negative 19, and negative 16. Yeah, that looks good. Okay, so let's get out of there. Okay, so now that we've done that, we're going to do our window setting, which is that zoom 9, zoom stat. So there's the points, nice sine wave. So it looks like we're good and we're in the right direction. So let's quit second mode, and now we're going to do the sine regression. So stat, over to calculate, and I can go all the way down to sine, or here's a little shortcut. I just press the up arrow and it takes me down to the bottom of the list. Okay, so remember we just want that as 1. List 1 is X, list 2 is Y, forget the period, and store the regression in in Y1. So alpha trace Y1 and enter. Perfect. Now it copy pasted it into Y1. So let's copy this over because we're going to use that. We're going to need that in our question. So let me just copy paste that over. And then let's look at our graph. Perfect. Looks great. Okay, So as soon as I have my graph, I'm going to deselect my plots. Just makes all of my calculations so much cleaner. So see, I've unhighlighted it and go into the question. Okay, so I have the graph, and while I'm here, I already know they're going to ask us for the temperature on August the 8th. August the 8th month of the year. So August is a X value, and it is an example of X given, Y needed. I'm going to use my trace function. So I'm going to go trace and enter in 8, press enter, and that will give me the temperature for August. So we'll call it 19 degrees because all the other numbers were to the nearest whole. So 19 degrees. So let's go back over here and look at our question. So the average monthly temperature, before I forget that, for August, 19 degrees Celsius. Okay, so looking at my regression, covering up my table of values, but we don't really need that anymore. Let's write out our equation. So our equation is going to be y equals 19.3 sine of bx plus c, or in this case minus c, plus 1.8. Now remember that the calculator doesn't factor b out, but we do, so let's rewrite that as 19.3 sine of b, which is 0.5. Factor that out. Remember, when I factor out a 0.5, it's like doubling, so it'll be minus 4.2 plus 1.8. Perfect. Okay. Next question says, in the context of the problem, what is the meaning of the parameter d? So in this case here, d is 1.8. It's a y value, so it's degrees Celsius. So what d is midline, which is average. So this is the average temperature for the year in Winnipeg. So if you were to ask, like, what is it on average, that means take out the highs, the lows, right in the middle, it's about 1.8 degrees Celsius, which is pretty chilly. That's why we call it Winterpeg. Now, how would the equation change if the table showed the average temperatures were for Veradero, Cuba? Okay, so if this was Cuba, not Winnipeg, what would change? Well, I think that the D value would be quite a bit higher than 1.8. So I think that we would definitely have a higher D value. And then the other thing is, look at my A value. My A value is quite high. So this is 19. So what that means is from the average of 1.8, we'll call it about 2, it goes up 19 degrees and it goes down 19 degrees. So it fluctuates quite a bit, cold to hot. I think in Veradero, Cuba, the temperature is pretty static or constant throughout the year. So I think there's going to be a lower, it's not going to vary 19 degrees back and forth. So I think that if this was in Cuba, there will be a lower A value, which is the amplitude. Higher D, lower A. So I hope you liked this video using sine regression. The steps, once you've done them a couple of times, are not too bad to manage, and it's a nice way of coming up with the equation without doing all the different steps. So if you have to come up with a sine equation using a table of values, this is another option that you can think of. And remember, when you're looking at your graphs, you're looking for a nice sine wave. Maybe like this, a sine wave. Okay, that was pretty bad. But I hope this video helped. The video is probably better than the joke, right? And I'll see you for the next one.